UFO's shape is traced onto the floor with precise measurements before any building begins. Metal rods are then cut, bent, and welded together to form a structural frame that acts as the foundation of the mold. Soil is packed over the marked area and carefully shaped around the frame to form the vessel's cabin outline, creating a cavity ready to receive mortar. Once the mortar dries and becomes firm, a release agent is brushed on. This produces a rigid negative mold that will serve as the base for building the UFO-shaped watercraft's cabin. Fiberglass chopped strand mat is then placed over this mold, and a liquid polymer resin is poured on top, which cures and fuses the fiberglass layers into a solid shell. A metal framework is erected around the watercraft to keep it stable and accessible throughout the remaining construction phases. The cabin's outer walls are formed by layering fiberglass mat and polymer resin directly over the supporting frame. Using the same technique, various additional structural pieces are fabricated to serve as key components during assembly. The negative mold is then carefully detached from the outer shell. The edges of the fiberglass structure are trimmed clean, and the whole surface is sanded down to a smooth, uniform finish. Hexagonal pieces are cut from drywall, according to the cabin's design, acting as placeholders for the window openings. Rectangular molds are then fixed onto the dome area of the watercraft to form slots for natural light entry. Finally, a mold for the main entryway is attached, giving shape and structure to the entry point. On the interior walls, fiberglass mat and resin are applied in a hexagonal pattern, forming a geometric surface finish. This approach results in a cabin interior that is both lightweight and structurally sound, while looking visually striking. The bottom portion of the watercraft is constructed following the same steps used for the upper cabin, with the only difference being the absence of a dome. For those who have been following along and enjoying the build, a like and subscription would go a long way in supporting the channel. The keel is then shaped and attached to the underside of the vessel. Its purpose is to counteract lateral drift caused by wind or water currents, allowing for steadier and more controlled movement on the water. All joints and gaps across the hull are sealed with fiberglass mat and resin to make the structure fully watertight, and any leftover material is cut away and discarded. The propulsion unit is mounted onto the keel and locked in place with extra supports. Rubber bushings built into these supports absorb vibrations from the engine, keeping everything firmly in position. Assembly of the propulsion system begins with the jet drive unit, which pulls water in and forces it out through a nozzle at high speed to push the craft forward. A drive shaft is then fitted between the jet unit and the engine to transfer rotational power through the system. After an intake cutout is added, the hull's underside is finished with a black protective coating to boost durability and resistance to water damage during use. At this stage, the core construction is complete. The watercraft now has its full skeleton in place, including the upper and lower hull, the keel, and the propulsion system. The door and window molds are removed, and all opening edges are neatly trimmed and smoothed to prepare them for doors, glass panels, and other finishing elements. The exhaust system is put together next, with a water box installed to act as a muffler. This component blends cooling water with hot exhaust fumes, reducing both the heat and the noise before they exit the vessel. The hose is firmly pushed onto its fitting, and clamps are used to connect the water box to the exhaust manifold and pipe. Cooling water is fed into the exhaust line to bring down gas temperatures before release. The overall exhaust setup handles noise dampening, engine cooling, and back pressure control all at once. A small pipe is fitted for the steering linkage, which runs from the handlebars to the steering nozzle. Turning the handlebars causes the nozzle to shift left or right, redirecting the water jet to steer the craft. The linkage is threaded through pre-drilled holes in the hull and aligned with the internal structure before being connected to the handlebar assembly. This direct connection ensures responsive and accurate steering through the rear nozzle. Once the opening edges are fine-tuned for a snug fit, the driver's seat is bolted securely into its spot inside the cabin. The engine housing is built from drywall boards coated with fiberglass mat and resin, producing a corrosion-resistant casing well suited to a marine setting. The entry doors made from the same fiberglass and resin combination used throughout the build. After shaping, a protective coating is applied, followed by a skim of plaster to level out any surface flaws. An extra layer of fiberglass and resin is added for reinforcement. The doors then split into two halves to make boarding easier and improve day-to-day usability. Edges are trimmed and smoothed after cutting for a clean and safe finish. An opening mechanism is built from metal bars, heavy-duty screws, and power tools. The bars are cut and shaped into hinges and support arms that allow each door half to swing smoothly. The system has two main parts: a fixed section that stays in place, and movable sections that handle the actual opening and closing motion. The hinged bars are fastened securely to the fixed part of the assembly. Both door halves are then coated with matching marine-grade paint in multiple even layers for full water resistance. A fabric lining is applied to the door's interior face to give it a neat, finished look. Beyond aesthetics, this layer hides any minor surface irregularities or texture inconsistencies left over from fabrication. The spot for the locking mechanism is marked on the door and carefully cut out. The mechanism is bonded in place with strong adhesive and further secured with screws to handle the demands of regular use in a marine environment. A push-pull control rod system is assembled to transfer motion from an actuator to the hinged door sections, allowing precise and dependable movement. A servo motor is fitted to manage the open and close function, turning in response to control signals to drive the linkage. A threaded rod is attached to the actuator as the push-pull connector. A coiled spring is added for shock absorption, and a wire links the actuator to the control system. The same fabric lining used on the doors then applied across the entire cabin interior for a consistent finish. LED lights are fitted into the cabin's openings, with wiring tucked neatly behind the panels and connected to the power supply and control system. These lights serve both a practical and decorative role, improving visibility while adding to the futuristic character of the build. The dashboard is mounted and wired into the vessel's electrical and control systems to enable full operation. The fuel tank is placed under the driver's seat, keeping the weight balanced and making good use of the available space. Fuel lines are routed carefully from the tank to the engine to prevent any risk of leaks, ensuring dependable fuel flow during operation. All engine connections, wiring, and piping are secured according to the engine layout, so the system is fully ready to run. The accelerator pedal is put together from several parts: the pad, the arm, the pivot, the return spring, and the linkage, all working as one unit. The linkage ties the pedal to the propulsion system, so that pressing down on it controls fuel flow and adjusts the craft's speed accordingly. Cast acrylic panels are cut to fit each window opening precisely, a technique widely used in DIY builds as an alternative to glass for boats, vehicles, and structures. The panel edges are cut and primed before an automotive ceramic tint film is applied. These films block heat and UV rays through absorption and reflection, without using metallic coatings that could disrupt onboard electronics. They also add a level of privacy and shield the cabin interior from sun-related wear and fading. To everyone who watched right to the end, thank you sincerely. Your support genuinely matters to the whole team. You represent the most committed part of the audience, and that dedication means everything. The goal is to keep improving with every new project. If you found this video worthwhile, hitting like and subscribing makes a real difference. Thank you again. This solar array converts sunlight into usable electrical energy, offering a renewable source of power for the batteries and onboard systems. The acrylic window panels are then set into their openings and sealed with marine-grade silicone adhesive, which forms a flexible, watertight bond capable of handling the movement and stress of open water use. With that, the UFO-shaped watercraft is fully built and prepared for its maiden voyage on the water. It is ready to bring the creator's original vision to life. After an enormous investment of time, skill, and creativity, what started as an idea has become something real and remarkable. Every element, from the fiberglass cabin to the propulsion system, reflects the dedication that went into making it. This vessel is not just a functioning watercraft. It is proof that even the boldest concepts can be realized through hard work and persistence. If this build inspired you in any way, subscribing to the channel will keep you connected to many more ambitious projects ahead.